Welcome to the lecture series of Basic Chemistry. Today's learning outcomes are we are going to talk about equilibrium and energy. So the first topic is equilibrium. Here you can see a picture depicting a reaction that is H2 plus I2 gives 2Hi. H2 means hydrogen, I2 means iodine, and they are giving the product hydrogen iodide. Okay. Now you can see that there are two arrows. So this is a double arrow reaction. What does this mean? That this double arrow is showing the forward reaction plus the backward reaction. That means this reaction is in equilibrium state. Now let us understand about equilibrium state in detail. So the concept of equilibrium is widely used in sciences and especially in chemistry. So a chemical reaction is said to be in equilibrium when the reactant and the products are in a constant ratio. The forward reaction and the reverse reactions occur at the same rate. Okay, so here in this graph you can see that in the x-axis we have time and in the y-axis we have the reaction rate. So you can see when H2 and I2 are reacting, then they are giving 2Hi. Okay, and similarly in the backward reaction, when 2Hi will break down, it will give H2 plus I2. So in both the reaction, in forward and backward reaction, the rate is same. Okay, and that's why this particular system is said in equilibrium. Okay, so this was a short example of equilibrium. Let us talk more about equilibrium. A system of chemical substance at equilibrium, even though having an unchanging composition, is most often not static. That means you can see that the composition is not changing in a reaction. So you will say that so this is a static reaction, but it is not so, because the molecule of the substance continue to react with one another and give rise to a dynamic equilibrium. The concept describes the state in which the parameters such as chemical composition remain unchanged over time. Okay, so this is what equilibrium tells about a chemical reaction. In the context of chemistry, energy is an attribute of a substance. So we have understood about equilibrium. Now let's move towards a new topic, energy. Okay, so what is an energy? It is an attribute of a substance as a consequence of its atomic, molecular and aggregate structure. So there is always a transfer of energy when one compound changes into some another. A chemical transformation is accompanied by a change in one or more of these kind of structures. Okay, and it is invariably accompanied by an increase or decrease of energy of the substance. Okay, if a substance's energy will decrease, you can see a different product. It is going to be changed in a different product, and when the energy will increase, the same thing is going to happen. Okay, so the increase or decrease in a substance makes the chemical transformation. Some energy is transferred between the surroundings and the reactant of the reaction in the form of heat or light. Okay, so you can see that there are some chemical compound which are not placed in open atmosphere. Okay, in open. Why? Because they may react with their surrounding and give some explosion. Okay, so that's why it is written that energy is transferred between surroundings and the reactant of the reaction. The product of a reaction may have more or less energy than the reactant. It depends on how much energy it have used. Okay, so to understand this, we are going to understand a term first, that is activation energy. So there are two types of reactions. First is exergonic, or we can say endothermic reaction and exothermic reaction. Now there are two more terms, that is exergonic and endergonic. So what is exergonic? So a reaction is said to be exergonic if the final state is lower. Final state means the state of product is lower on the energy scale than the initial state. Initial state means the reactant when it was going to get react. And endergonic is the reverse of this. Okay. Now what is exothermic? It is more easier to understand. A reaction is exothermic if the reaction releases heat to the surrounding. Okay. So when there is a reaction going on, so suppose there are two reactant. When they react, some heat has released, so that is a exothermic reaction. And when there are two reactant and they are reacting, but they are not reacting until they are given some heat, okay, or some another source, so that will be an endothermic reaction because it is absorbing heat and then it is reacting. Okay, so this is the difference between exothermic and endothermic reaction. Chemical reactions are invariably not possible unless the reactants surmount an energy barrier known as the activation energy. So this is what I was talking about. So it's not that every chemical react without any external thing. Okay, so there is always, so every time a reactant have to achieve some energy barrier, that is its activation energy. That means the reactant is now activated and it is ready to give some product. Here in this figure you can see that in first it is shown the initial state of reactant, and then when it is attaining its energy barrier, that is its activation energy, when it is activated, then it's giving a final product. And you can see the level of energy is different. In initial state you can see some low energy, and in final state you can see more energy. So this is how energy changes from one substance to another. Okay. Now the speed of a chemical reaction at given temperature T is related to the activation energy E. Okay. That means if suppose the temperature is 50 Kelvin, only suppose, okay, some substance is getting activated on 50 Kelvin, but some another substance is not getting activated in 50 Kelvin. So the chemical reaction speed of both the substance will be different. That's why it is said that the speed of a chemical reaction is related to the activation energy and in a particular given temperature. Here is a term, Boltzmann population factor. So it is the probability of molecule to have energy greater than or equal to E at the given temperature T. Okay. So this exponential dependence of a reaction rate on temperature is known as Arrhenius equation. Okay. So the figure I have shown you earlier, it is also showing the Arrhenius equation. The activation energy necessary for a chemical reaction can be in the form of heat or light or electricity, or you can say some by giving some mechanical force also some reaction happens. Okay, so this was all about energy. Now let's talk about some objective questions related to today's topic. So the first question is, what is the representation of a reversible reaction? Option A is single arrow, B double arrow, C bar, and D none of the above. So we have seen reversible an example of equilibrium reaction, right? So there we saw the reversible reaction, and a reversible reaction is always shown by a double arrow showing the forward and the backward reaction both. Okay, next question is, what is the term used for a state of a chemical reaction in which forward and reverse reactions take place at the same rate? So the answer is chemical equilibrium. It is also the definition of equilibrium state. All the other three options are incorrect. So these were the topics today we have covered. Thank you so much for watching this video.